Right now, there is a magnet stuck to your fridge. You barely notice it. It just holds a photo, or a note, or a shopping list. But that little magnet is doing something invisible. Something most people never think about. Inside it, trillions of tiny particles are all pointing the same way. And that's the whole secret. Ready to see it? Let's start small. Every magnet is made of atoms. Inside every atom, tiny particles called electrons are spinning around. Think of an electron like a spinning top. And every spinning top makes a little push of invisible force around it, called a magnetic field. A magnetic field is just an invisible zone of pull, like the wind you can't see but can still feel. In most materials, these spinning electrons point in random directions. Some point up, some point down, some point sideways. All that randomness cancels out. So most objects have no magnetic pull at all. That's why your wooden table doesn't stick to your fridge. But in a few special materials, like iron, something different happens. The electrons like to line up. Not perfectly on their own, but they're ready to. Imagine a crowd of people all facing different directions. Now imagine someone blows a whistle, and they all turn to face the same way. That's what happens inside iron when it becomes a magnet. So how do you get them to line up? You expose the iron to another strong magnet, or you run electricity through a coil of wire wrapped around it. Electricity flowing through a wire creates its own magnetic field too. That's a strange fact, but it's true. Moving electricity and magnetism are actually two sides of the same coin. Once enough electrons inside the iron turn to face the same way, their tiny pushes stop cancelling out. They add up. And now the whole object has one big invisible field, stretching out from one end to the other. We call these two ends poles. One is called north. The other is called south. Here's the part that surprises people. Opposite poles pull toward each other. North pulls south. But two of the same poles push apart. North pushes north away. Why? Because the invisible field lines are trying to connect. They flow out of the North Pole, curve through space, and dive back into the South Pole. When two magnets face opposite poles toward each other, the lines connect smoothly, so they snap together. When the same poles face each other, the lines crash into each other and shove the magnets apart. You can't see any of this with your eyes. But you can feel it in your hands. That little resistance when you try to push two magnets together the wrong way? That's the field lines fighting back. Now here's the really clever part. This tiny effect, happening inside a piece of metal the size of a coin, is the same basic idea that powers giant electric motors, spins the hard drive inside a computer, and even helps compasses find north by lining up with the Earth's own magnetic field. Yes, the whole planet is a giant magnet too, with molten iron swirling deep inside it, way down at the core. So that little fridge magnet isn't just holding up your shopping list. It's a tiny army of electrons, all facing the same direction, creating an invisible field strong enough to grip metal from across a small gap. Next time you press a magnet onto your fridge, pause for a second. Feel that little click as it locks into place. That's not just plastic and metal meeting. That's an army of spinning particles, all lined up, all pulling together, doing their quiet, invisible job.